Okay, so we're going to talk about radical addition of HBr across a double bond. This is done with a radical, and that's why we're talking about it now, although we talked about it in Chapter 9 already, so hopefully this will look familiar to you. Recall that when we add HBr across a double bond, right, boom, boom, and so then the hydrogen goes to the more substituted, right, so that we can get the carbocation, the less substituted, so that we can get the carbocation at the more substituted, right? And then the bromide, which is left, right, boom, goes in there. And so that's where we get Markovnikov addition of HBr. That's without peroxides. But with peroxides, which are radicals, okay, or make radicals, I should say, because that OO bond is weak, so it makes a radical very nicely. With peroxides, we get anti-Markovnikov addition. All right? So, and it goes through a radical mechanism of addition, which we're not going to talk about. Yeah, we're not going to talk about that. We're not going to go through that. But since it has a different mechanism, it's got different selectivity. Okay, so I think the big take home for this section is to memorize that reaction. Let's go on to the next slide. All right. And I guess I do also want you to remember that if we form a new chirality center, then if the substrate's not chiral, a racemic mixture is going to be found, and if it is chiral, then we're going to get a diastereomer, okay, or diastereomers, right? So just don't forget to consider the implications of the structure that is produced.